see Lindelof videos, geometry. Today we're going to be learning how to prove triangles congruent by SAS and HL. So SAS, or side angle side, is the side angle side congruence postulate. So it says if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So here we have two triangles. This is triangle RST and this is triangle UVW. So it's given here that this side is congruent to this side and that this side is congruent to this side, and these angles are congruent as well. So if we were to write that, we could write if side RS, doesn't look like an S, try that again. Side R, doesn't look like an R either. Side RS is congruent to side UV, and angle R is congruent to angle U, and side TR is congruent to side WU, then triangle RST is congruent to triangle UVW. And that's pretty simple. It's just following the rules of that. If your two sides are congruent and your angle is congruent, then your triangles are congruent. The next theorem is the hypotenuse leg congruence theorem, or the HL congruence theorem. And this only applies to right triangles. Okay, so draw two right triangles. That was really bad. Oh, don't judge my triangles. Okay, so here's your 90-degree angle, and this is congruent to this side, to this side. Okay, so this is, it's right there. How about A, B, C, and this is D, E, F. That's a C. Okay. So let's just quickly go over what a hypotenuse is and what a leg is. So leg of a right triangle are these two sides here. This and this. So on this side is right here and right here. And then your hypotenuse is this angle right here. Basically, your legs are the sides that make up the right angle. And then I like to think of hypotenuse as closing that. So now that we know what a hypotenuse and a leg are, now we know what a hypotenuse and a leg is, right? Now we can look and see how we can answer this question or figure this out. So AB, this leg AB is congruent to this leg DF. It's given. And the hypotenuse AC is congruent to the hypotenuse DE, which is also given. So since we know that, we can say that triangle ABC is congruent to triangle DEF. And again, we're just following the rules given to us in the congruence theorem. So not too difficult. Now let's look at some problems. Okay. It says here to decide whether the congruent statement is true. So the first one says QRS, triangle QRS, is congruent to triangle TUS. So we can look to prove that this is true or untrue. Or I guess true or false. So we can say that side Q, why is that happening? QS is congruent to side TS. You can also say that side RS is congruent to the side US. And angle S is congruent to angle S because they share point S. So of course that angle is going to be congruent. And you can also look at it and see that all of the sides are congruent to each other. So we know that if the sides are congruent and the angle is congruent, this is true by the side angle side theorem. Okay. The next one says that triangle DEF, which is here, DEF, no, sorry, it'll be this way. If you were to trace it, it would look like this. DEF is congruent to triangle GHF. So we can then look to see DE. So first, just look at this. This triangle is not, no, try that again. This triangle is a right triangle because we know because it has a 90-degree angle in it. So we know that if we're going to be proving this true or false, we're going to be proving it by the hypotenuse leg theorem because it's a right triangle. So it's saying that this leg, which is EF, is congruent to GF. And the hypotenuse DE is congruent to the hypotenuse GH. So we can look. So we can see that DE is congruent to GH. However, EF is not congruent to HF because EF is this shorter leg and HF is this longer leg. So this is not true, but if you were to say that triangle DEF is congruent to triangle HGF, we could look and see if that could be true. So we know that DE is congruent. Oh, I'm stuck. DE is congruent to HG. It's here to here, going here to here. And also EF is congruent to GF. So it's this shorter leg here. So I hope you found this helpful. If you did, please give it a thumbs up and subscribe. And I'll see you soon.